Hi everyone, myself Deepika Devi. Here I am going to teach about Intel 80486. Welcome to my YouTube channel. Intel 486, the 32-bit 80486 is a revolutionary step up from the 80386. One of the most obvious feature included in a 80486 is a built-in Max coprocessor. This coprocessor is essentially the same as the 80387 processor used with a 80386, but being integrated on the chip allows it to execute max instruction. 80486 is an 8K bytecode and data cache. To make a ROM for the additional signals, the 80486 is packaged in a 168 pin Memory Management Unit. In Memory Management Unit, there are two types of Memory Management Unit. One is Segmentation Unit and one is Paging Unit. Uses of two address components, segments and offset for relocability and sharing of data. It allows a maximum segment size of 4 GB. Paging Unit. It organizes physical memory in terms of page of 4 KB size. It converts linear addresses into physical addresses. It works under the control of segmentation unit. Here, this is the pin diagram for Intel 80486. Pin definition: A31 to A2 address outputs. A31 to A2 provides the memory and input-output with the address during normal operation. During a cache line invalidation, A31 A4 are used to derive the microprocessor. A20M3, the address bit 20 mask causes the 80486 to wrap its address around from location as in 8086. This provides a memory system that functions like the 1M byte. A hold. The address hold input causes the microprocessor to place its address bus connection at their high impedance state, with the remainder of the bus staying active. BE3 to BEO. Byte enable outputs select a bank of the memory system when information is transferred between the microprocessor and its memory and input and output. Break. This bus request output indicates that the 486 has generated an internal bus request. Blast. The burst last output shows that the burst bus cycle is complete on the next activation of BRDY. NMI. The non-maskable interrupt input requires a type 2 interrupt. RDY. The ready input indicates that a non-burst cycle is complete. The ready signal must be returned or the processor places wait status into its timing until ready is asserted. BOF. The back of input causes the microprocessor to place its buses at their high impedance state during the next cycle. The microprocessor remains in the bus hold state until the BOF pin is placed at a logic 1 level. Here, this is the architecture of 80486 Intel pin. 80486 signal group. The 80486 requires 1 clock instead of 2 clock required by 80386. A new signal group on the 486 is the parity group DP0 to DP3 and PCHK. These signals allows the 80486 to implement parity detection or generation for memory reads and memory writes. During a memory write operation, the 80486 generates an even parity bit for each byte. These bits will store in a separate parity memory bank. Another new signal group consists of the burst ready signal BRDY and burst last signal blast. These signals are used to control burst mode memory read and write. During a read operation, the stored parity bytes will be read the parity memory E flag register of the 80486. The extended flag register E-flag is illustrated in the figure. The only new flag bit is the AC alignment check used to indicate that the microprocessor has accessed a word at an odd address or a double word boundary. Efficient software and execution requires that the data be stored at word or double word boundaries. Here is the picture of E-flag register of the 80486. 80486 memory system. The memory system for the 486 is identical to 386 microprocessor. The 486 contains 4G bytes of memory beginning at location and ending. The major change to the memory system is the internal to 486 in the form of 8K byte cache memory. Another addition is the parity checker or generator built into the 80486 microprocessor. Parity checker or generator is often used to determine if data are correctly read from the memory location. Thank you so much.